Okay, this is the big part of this chapter. It's called the factor theorem. It has to do with finding factors and finding remainders and actually doing some factoring of polynomials. So the factor theorem, very, very similar to the remainder theorem. The factors of a number are really going to be the whole numbers, or maybe I should say integers, the integer numbers that can multiply to give another one. For example, the factors of 12, we know it's going to be 1 and 12, and 2 and 6 and 3 and 4. Now they could be plus or minus, right? Could be positive or negative, depending. Two negatives make a positive, right? So the factors of 12 are going to be these. Now, there's 1, 2, 3, 4, 5, 6, so 12 different factors. Now, yes, I know you could say it's 24 and a half, right? But there's an infinite number of fractions that would work. So let's not go to the fractions. Let's just try and go with the integer values that are actually going to give me 12. So an alternate way of defining what the factors are is saying that these are numbers that will divide evenly into a number. In other words, with a remainder of 0. So when you divide it in, there's no remainder left over. So what do you mean by that? Well, let's think about it. 5 is a factor of 100. It is, because if I go 100 and I go divide by 5, that gives me 20 with a remainder of 0. There is no remainder. There's nothing left over. 10 is also a factor, because 100 divided by 10 is going to give me 10. Exactly 10. There's no remainder. There's nothing left over. 6 is not a factor of 100. Here's why. Because if I go 100 divided by 6, well, it gives me 16, because 16 times 6 is 96. I have a remainder of 4, right? So if the remainder is anything other than 0, it's not a factor. I don't want 6. 6 is not going to work. These are the ones that divide in evenly. Now, we really shouldn't say even, because I'm not thinking about even and odd. What really this should be, they divide completely. Okay? They divide completely, and they completely go in. There's no remainder left over, right? Don't think of even and odd. When you say it divides in evenly, it really should be completely. Okay. So that's called the factor theorem. X minus a is a factor of some polynomial if the remainder is 0. And remember, I had a shortcut. If I want to know the remainder, I plug in P of A. You plug in the opposite number. If this is x minus 2, I'm going to plug in positive 2. So if and only if P of A is equal to 0. If, IFF, this means if and only if. That's actually it's actually a term, if and only if. We haven't really seen this. You will see this in logic courses and stuff like that. What it means is that you can read it forwards and you can read it backwards. So this implies this and this implies this. So in other words, forwards and backwards. That really means x minus a factor implies P of A is equal to 0, and the other way around. If P of A is equal to 0, then you know it's a factor. P of A equals 0 implies x minus a is a factor. Okay? Not a huge deal. We haven't really seen this before, but most of the things we've seen imply one and backwards. For example, Pythagoras. If it's a right triangle, then Pythagoras works, and the other way around. If Pythagoras works, then I know it's a right triangle. That's the if and only if thing. When you get into logic courses and other places, some things don't always work that way. So for example, if it's raining, that means I have an umbrella. So if I have an umbrella, does that mean it's raining? Not necessarily. Maybe I'm a crazy person. I don't know. Maybe I'm afraid of the sun. Maybe it's not a parapluie. Maybe it's a parasol. So if and only if is what this means. It's not a misprint. Okay. Bottom line is we're going to use this to figure out if things are factors. So let's try this. Which binomials are a factor of this polynomial? So here's my big polynomial. So is x plus 1 a factor? I don't know. Let's figure out the remainder, because the remainder is p of negative 1. Remember, I'm going to plug in the opposite. So take negative 1 and plug it into this polynomial. So this is negative 1 cubed minus 3 times negative 1 squared minus negative 1 plus 3. Right? So let's be careful using brackets, thinking about these things. Negative 1 cubed is just negative 1. We know that. Negative 1 squared is 1, so this is minus 3 times 1. This is minus 3. Minus minus plus 1 plus 3. 3 minus 3 gone. 1 minus 1 gone. This is equal to 0. That's the remainder, which means this thing is a factor. If I was to divide this factor into here, it would divide in completely with no remainder. Let's try -1. Oh yeah. Hang on, let's try this. So in other words, p of +1. So I'm going to take +1 and plug it into the polynomial. That's the best one to plug in. I'm just plugging in ones. So it's going to be 1 minus 3 minus 1 plus 3. So this is 1 minus 3 plus 1. No, minus 1. And then plus 3. Guess what? These cancel, these cancel. This gives me 0. Yes, this thing is a factor. Because there's the remainder. The remainder is going to be 0. Okay, let's try the other two. What about x plus 3? Let's try that. So in other words, my shortcut for finding the remainder, I'm plugging in -3. So let's take -3 and plug it into this polynomial. So that's equal to, well, -3 cubed minus 3 times -3 squared minus -3 plus 3. -27. This is +9 times -3 minus 27. Plus 3 plus 3. Okay, so this is -54 plus 6 is -48. That's the remainder. No, that one's not a factor. So in other words, if I was to divide this into this, it's not going to work. No. X minus 3? Let's try this last one. So in other words, I'm plugging in, I'll get rid of this stuff here. What's p of +3? So remember, I'm just taking +3 and I'm plugging it in. 3, 3, 3, 3. Okay, so this is equal to 3 cubed minus 3 times 3 squared minus x and then plus 3. So look what we get. We get 27 minus 27 plus 0. This is equal to 0. Yes, this one is a factor. Ta-da! Okay, so I found these 3 factors are the factors of this polynomial. Who cares? Very good question. Why? Why did we bother doing all this stuff? Because here's what we did. I know that this polynomial can be written as this factor times this factor times this factor. So in other words, my polynomial is x minus 1 and x plus 1 and also x minus 3. See what we did? We just took this cubic polynomial and we broke it down into these 3 factors. You know how to factor. Hang on. Think about this for a sec. If I was to ask you to factor a trinomial, right? X squared plus 4x plus 3. You know how to factor that. You say, look, I know what it's got to be. X squared, it's got to be x and x. 2 numbers multiplied to 3, it's got to be 1 and 3. And they add up to 4. Right, that works. That only works for trinomials, for quadratics, right? That little system of 2 numbers multiply to this and add up to that, only for quadratics. As soon as I change this into an x cubed and an x squared, that no longer works. You can't do that anymore. So, but I'm expecting this to turn into 3 different factors. And there they are. See? There's my 3 factors. And by the way, take a look at this. X times x times x. I know if I was to expand it all out, and we did expand them all out, it would start with an x cubed. And what about the coefficient on the end? The plus 3? Well, if I was to expand this thing all out, I know it's going to be minus 1 times positive 1 times minus 3. That's where I get the plus 3. So the x's give me the leading coefficient, and the constants give me the end coefficient. That's really the important one there. Because I factored that into these 3 factors. Now, where did these come from? Well, I just made them up. I just guessed. What about x minus 1? What about x plus 1? Right? I took the factors of 3. They have to be the factors of 3. Oh yeah, think about it. If I was to expand this thing all out, the last number is going to be this times this times this. So the factors of 3 on the end are, the constant on the end is important because it's going to tell you ones to guess. And I guessed them. I just guessed them. So that is known as the integral zero theorem. What? The integer. Let's just think about whole numbers, positives and negatives, right? The integral zero theorem says if x minus a, if something is a factor, right, then a has to be a factor of the constant on the end. And we call that a sub 0 or a naught, right? The constant on the end of the polynomial, that's what, so that's where I'm actually going to start. I'm going to look at the constant at the end, and that's where I'm going to guess. So what do you mean? Here's some kind of weird polynomial, right? If I wanted to factor this thing, I need to guess. So what are my possibilities? The possibilities are going to be plus or minus 1 and 3. Those are the factors of 3. So you know what? I'm going to guess positive 1, negative 1. Positive 3, negative 3. Those are my only possibilities. Guaranteed 2 is not going to work because 2 is not a factor, not a nice whole number factor. Okay? So this is what I do. I'm going to start with these possibilities. So let's try P of 1. Let's plug in 1. Plug in 1. What do I get? I get 2 minus 5 minus 4. So I get 2 minus 5 minus 4 plus 3, which is 5 minus 5, which is 0, which is minus 4. That's not 0, which means this thing's not a factor. So this is useless. I don't want this. Not good. Oh, maybe I should keep all that stuff there. Okay, let's try negative 1. Negative 1, plug it in. So 2 times negative 1 cubed. Negative 1 cubed is negative 1. So it's 2 times negative 1 cubed minus 5 times negative 1 squared. 4 times negative 1 plus 3. Here's what I get. Negative 2 plus, no, positive 1. So minus 5 plus 4 plus 3. Negative 7 plus 7. This is equal to 0. Okay, so that's a good thing. I want to plug in my possible numbers until I get a 0. Once I get a 0, I know that, what is it? Negative 1. So this is x plus 1 is a factor. I know that. I know that as important because that's from the factor theorem. If the remainder is 0, that means this is a factor. So I know that this should divide into that. So let's divide it in. Do you want to do it by long division or synthetic? Let's do it by synthetic. Synthetic is way faster. We can do synthetic division. So how do we do the synthetic division? 2, negative 5, negative 4, 3. 2, negative 5, negative 4, 3. My factor is x plus 1 here. I'm not going to put a plus 1. I'm going to put a minus 1 because that way I can add every single time. Okay, 2 comes down. Negative 1 times 2, negative 2. Add them up, negative 7. Negative 1 times 7, positive 7. Add them up, 3. Negative 1 times 3, negative 3. Add them up, 0. Remember, this is your remainder. I knew the remainder was 0. Psst, we already knew that. So that's a good check. This has to be 0. What is this? This is the quotient. So this is the constant, the x, and the x squared term. So in other words, remember, the polynomial is the divisor, which was x plus 1, times the quotient, which is this, 2x squared minus 7x plus 3, plus the remainder. You don't need to say plus 0. We can get rid of that. So I took that big cubic and I broke it down into this. I'm expecting this to be 3. That's a trinomial. I can factor that the old-fashioned way. Remember, two numbers multiplied to 6, add up to negative. It's got to be negative 1, negative 6. Okay, let's try that. 2x squared minus 1x minus 6x plus 3. Remember, that's the way this works by decomposition. I can factor out x, bracket 2x minus 1. Here I can factor out 3. Negative 2x plus, hang on, those are not the same. Don't factor out negative 3. No. Factor out positive 3, or the other way around. Let's factor out negative 3, bracket 2x minus 1. Oh, I can see it now. 2x minus 1 is one of the factors. The other factor is x minus 3. And there's the other factor. So this is actually going to be x plus 1, bracket, x minus 3, bracket, 2x minus 1. Let's just get rid of this little bit of stuff here. So here's what you did. You factored the polynomial, which was this cubic, right, into 3 individual factors. 1, 2, 3. So that's what my polynomial is. And remember, I can check this. X times 2x is 2x cubed. Works. 1 times -1 times -3 is positive 3. And there it is. It's positive 3. Now, this stuff in the middle kind of depends upon what the different factors are. We can't really guess that, but I can guess the first and last, and there it is. So congratulations. Now you're not just limited to factoring trinomials. You can factor anything. This will factor all polynomials. It could be x to the power of 10, and I would probably end up with 10 different factors. That's what I'm expecting. So what are the different steps that we did here? Okay, so my very, very first step was I wrote out the possibilities because I'm going to guess. You have to guess to get the first one. Don't guess 2. 2 is not a factor. Don't guess 17. 17 is not a factor. Factors of 3, if we're going to go for whole numbers, 1 and 3 plus or minus. So step 1, I write out my possibilities. So write possible factors of a naught, right, of the constant on the end. I'm going to sub into p of x until I get a 0. Because you're going to plug in a number, you're looking for 0. Once it's equal to 0, you know that's a remainder. To find a 0, and therefore you have a factor. Right? Once you have that first factor, now I can take that factor and I can divide it in. Divide it in by long division, divide it in by synthetic division, doesn't matter. Whichever one's easier. In this case, synthetic is awesome. So divide by synthetic division until you get the quotient for the quotient. Okay, once you have the quotient, then remember it's the factor times the quotient plus the remainder. So I write p of x is equal to my first factor, x minus whatever it is, times the quotient. Now, our quotient in this case turned out to be this trinomial. You can factor a trinomial. Now, you can do it this same method, doing what we did with all the synthetic division, or if it's a trinomial, you know how to do this by decomposition. By the way, you can probably guess these factors, right? 2x squared, I know it's got to be 2x and x, if I'm going to go for whole numbers, and 3's got to be 1 and 3. So it's either 1 and 3 or it's 3 and 1. You only have 4 possibilities. You'll probably be able to guess them, okay? And then, if possible, factor q of x, if possible. It's not always possible. So if, si possible, if possible. Okay, so use the integral 0 theorem and your calculator. We're not going to do all this stuff by hand. We're going to use the calculator. This is why I'm doing it on the board, because I want you to use your calculator. Let's see what we can do and how we can effectively use the calculator. Okay, so find all the factors. Now, it didn't say write out all the possibilities, but I'll do that here. My possibilities for 36, the factors of 36, well, it's 1 and 36, 2 and 18, 3 and 12, it's 4, yeah, 4, 9, wow. Oh, and there's also 6, man. So it's plus or minus 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 18 different possibilities. We're not checking those all by hand. We are plugging this thing into the calculator. Okay, so what is the polynomial? I'm going to plug that in as y1. So x cubed, x to the 3, plus 5x squared, minus 12x, and also minus 36, okay? That's what I'm going to plug in. Remember, if I go to second trace, if I go to my table, now if I've got it set up the right way, I can plug in any number I want. Remember, second format here, you want the first one to be ask, you want the second one to be automatic. So it asks you for the independent, the x, and it automatically does the dependent for you, right? So what do I want to do? Let's try 1. That's not 0. No good. Let's try -1. -20. No good. What else can we try? Plus or minus 1, plus or minus 2, plus or minus 3. Yeah. Let's try 2. Nope, no good. -2. Yes. Excellent. Negative 2 gives me a remainder of 0, which means x plus 2 is a factor. So I know one of the factors is x plus 2. Let's keep going. How about 3? Oh, 3 works. So it means x minus 3 is also a factor. Okay, x minus 3. At this stage, you can probably guess the last one, right? X, I know the last one's going to be x, right? That's how I get my x cubed. Negative 36, well, this is negative 6. I bet you this is, hang on, is this 6 or negative 6? 6. No, negative 6. Yes. So it's x plus 6. Yeah, you know what? You can probably guess this last one. So there you go. You just factored a cubic into 3 factors. So we did that on the calculator. Now we kind of cheated, right? Because I didn't actually do all the synthetic division and all that. But if you're just looking for the factors, there they are. Let's do the same thing here. My possibilities for the factors of 8 are 1 and 8, 2 and 4. So plus or minus 1, 2, 4, 8. So I'm going to try with 1, negative 1, 2, negative 2. These are the only integer numbers that are going to work. 7's never going to work because 7 is not a factor of 8. Okay, so let's go back to our graphing calculator. Now the nice thing here is I can just go up and delete. All you need to do is I just need to change this. Okay, so it's x cubed plus, what was it, 4x squared minus 8. 8. Delete, 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 delete. There, all I've done is I've just changed my polynomial. Second graph, 1, no good. What about negative 1? No good. What about 2? No good. Negative 2. See, this is way faster for plugging in numbers. Boom, there I go. Once I got a 0, I've got a factor. So I know one of the factors is going to be x plus 2. Okay, come on. Okay, I'm expecting it to look like this, right? Now there's going to be 2 more factors, right? Probably x and x. So we tried 1, 2, let's try 4 and 8. 4, no good. Negative 4, no good. 8, negative 8. Uh-oh. None of these give me zeros, which means they're not factors. So this is going to be a trinomial. I can probably guess what it is. I know it's got to start with an x squared, right? Right? In order to get my x cubed. The minus 8, I know it's got to be minus 4 on the end. I just don't know what it is in between. But it's not going to be 3 nice little factors because this one, they're not integer values. Now, if I wanted to know this, you could do this by synthetic division, right? And if I actually do it by synthetic division, let's try it. Remember, I'm going to put positive 2 out front. 1, 4, 0, minus 8. 1, 2, 6, 12, 12, 24, 16. So there's my quotient. Hang on, I messed up somewhere here. It's got to be 0. Can't be that. Let's double check this. Remember, this is a good check. This is how you know if something's a factor. 1 comes down. 2 times 1, 2. 6. Hang on, what am I doing? Am I doing this wrong? 1x cubed, 4x squared, 0 x's, minus 8. Should this be a plus 2? It's got to be a minus 2. I have to switch this. That's why it wasn't working. Oh, okay. Let's see. Minus 2. Bring it down. 1. Minus 2, minus 2. Add them up. 2. Minus 2 times 2, minus 4. Add them up. Minus 4. Minus 2 times minus 4. Oh, there it goes. Now I've got it. So that's why this is super important. You know that's got to be 0. There's my quotient. Minus 4. Hey, I already knew that. 1. And this actually turns out to be a plus 2x in between. Now, I didn't do that part on my calculator because the calculator will let you guess individual factors. But if there are no other ones, like this thing, that's it. That's as far. Now, some people might say, hey, why don't we use the quadratic formula? That's for equations. This is not equal to 0. That's it. That's factored. That's as far as you can go. The quadratic formula is just if it's equal to 0, if it's actually an equation. Okay, so we factored it. Okay, so here we go. This is the big question. Factor this beast completely. This thing is a quartic. I'm expecting 4, maybe 4. Well, let's see. So, step 1, possible factors. They're going to be plus or minus 1, 2, 3, 4, 6, right? What are the factors of 24? 1 divides in, 2 divides in, 3 divides in, 4 times 6, 3 times 8, 2 times 12, and 1 times 24. So 1, 2, 3, 4, 5, 6, 7, 8. So, oh man, there's like 16 possibilities, but there's only 16 integer possibilities. None of the other ones will work. Not all of them are going to work. I bet you only 4 of them will work, right? So, P of 1. I'm not doing this by hand, remember? Let's do it to the calculator. So x to the 4 minus 5x cubed. X to the power of 4. Subtract 5x to the power of 3. Okay, then what is it? And then it's plus 2x squared plus 2x squared. Where are we? Plus 20x and minus 24. Plus 20x, subtract off 24. Hang on, double check. My favorite thing to do with these questions is to write them down wrong, which means you're wasting your time. Double check. X to the 4 minus 5x cubed. Yes. Plus 2x squared. Yes. Plus 20x minus 24. Great. Go to the table. Oh, I can see some of the zeros already. So remember, we said the possible factors are plus or minus 1, 2, 3, 4, 6, 8, 12. So let's just plug some of those in. 1. No. Negative 1. No. 2. Yes. So P of 2 is equal to 0. That means x minus 2 is a factor. That's important. That's something we need to write down. This doesn't really tell me anything, but I do know from the factor theorem, if this gives me 0, if the remainder is 0, I have a factor, which means x minus 2 is going to factor into that. Okay, let's do it. So let's do it by synthetic division. 1, negative 5, 2, 20, minus 24. And instead of minus 2 out here, I'm going to put a positive 2. Remember? Switch it, and that way you can add. It's faster. 1 times 2, 2. Add them up. 2 times negative 3, negative 6. Add them up. 2 times minus 4, negative 8. Add them up. 12. 2 times 12 is 24. Excellent. Gives me 0. I know that has to be 0. Okay, so there's my 0. There's my quotient. Number x, x squared, x cubed. So in other words, the polynomial is my first factor, x minus 2, times the quotient, x cubed minus 3x squared minus 4x plus 12, plus 0. I don't need to say plus 0. So I factored out one factor. Now what? Now I continue the process. Okay, this is what I got to break down. So the same idea. I'm just going to continue. So it's a matter of, okay, what are the factors of 12? And let's do all that stuff again. But hang on, think about it. We already had our possibilities here, right? If it's a factor of this big beast, it's definitely a factor of this. So you know what? I tried 1 and 2. Let's keep going. Let's try 3. Let's try 4. Let's go back to our calculator, right? I tried 1. Did I try negative 2? Hey, negative 2 works. This is another factor. So I know that x plus 2, okay, x plus 2 is going to be a factor of this thing because it's a factor of the whole thing. It's also got to be a factor of this. Okay, so I know P of 2, no, it was negative 2, right? Was it negative 2? What did we plug in? I'm getting lost. Yeah, it was negative 2. P of negative 2 is equal to 0, which means x plus 2 is a factor. It's also a factor. Which means I should be able to factor it into this thing. I'm not going back to the original one. Let's go back to, because this part's already done. So let's do it. Okay, so Negative 2 out front. 1, negative 3, negative 4, 12. 1, negative 3, negative 4, 12. Those are my coefficients in the right order. Luckily, I don't have to put any zeros. 1 comes down. Negative 2, whew, negative 5. Whoa. Negative 5, 10. Add them up, 6. Negative 2, 6, negative 12. Yes, there's my remainder. The remainder is 0. Good. So if I divide x plus 2 out of this thing, there's my quotient. Number, x squared. Okay. What's our polynomial? X minus 2 is a factor. X plus 2 is also a factor. And then what was the quotient we were left with? It was this thing. X squared minus 5x plus 6. Okay. Continue on. Oh, I know how to factor that. It's just a trinomial. Two numbers multiplied by 6, right? Negative 6 and 1? No. 6 and negative 1? No. 2 and 3? They multiply to 6. So they're either both positive or they're both negative. They add up to 5. So it can't be 6 and 1. It's got to be 2 and 3. Minus 2, minus 3. So this one is an easy trinomial because I know it's got to be x and x. So minus 2, minus 3. How do I know that? Because x squared, and if I can factor it into integer values, that's kind of what I'm doing. Minus 2, minus 3. X plus 2, x minus 2. There's my polynomial. Now, x minus 2 is there twice, so if you want, you could probably make this one squared and do that. It's the exact same thing. Or, you know what? Don't. Some people like doing it this way because I can see there's 1, 2, 3, 4 factors. I can see x. That's x to the power 4. Negative 2, positive 4. Positive 8, negative 24. Negative 24 was the number on the end. Yes, it was. So there we go. That is completely, so you factored a quartic and you got it into 4 factors, which is kind of what we're expecting. They don't always break down. Sometimes this might be a trinomial that doesn't break down. Like if this was plus 7, then that's it. That's factored. Why don't you go to the quadratic? This is not an equation, right? Hang on, let's get back to here. Let's change this question now. What? No. What if this question was different? This was factoring, and we did it completely right. We're good. What if the question was this? Solve this equation. See, that's different. Now this is an equation equal to 0. Now my answer should be x equal to something, right? Now, I don't know how to solve that. It's not a parabola. It's some kind of weird shape. You could graph it on your graphing calculator, by the way, and you're looking for the zeros. That's all you're doing, right? Where is it equal to 0? The zeros of the polynomial. Or, basically, if you could factor it, and you do, if you can make it equal to 0, now you know what your answers are. X is equal to 2, negative 2, positive 2 again, and positive 3. There's the answers. I was expecting 4, but it's 4 or less. This one actually has 3 zeros. So if it's an equal to 0, you do this extra step. If, however, it's not equal to 0, you don't. That's your answer. Alrighty, so these ones have to do with a little bit of factoring, and remember the factor theorem says if it's a factor, that means the remainder should be 0, and your shortcut for finding the remainder is plugging in the opposite number. And these last few have to do with plugging in those numbers too, and I think this is a system. Alrighty, good luck with this. This is the there's one last thing to do after this, and then we're done.